Hello everyone, my name is Abdullah Al-Awadi and today I'm going to talk to you about data visualization. We will begin by giving an introduction to the topic, discuss what and why we should use data visualization. We will also touch on the benefits of using data visualization and give some examples of how we can use it. Finally, we will illustrate a real-world example of using data visualization using Tableau software. So in 2002, we generated around 2.5 billion gigabytes of data every day. And such creation of data has been facilitated by several technologies, including radio frequency identifiers, social media, video and audio streams, cell phone GPS data, and ERP systems. However, due to this, businesses are now so overwhelmed by the amount and complexity of these data cascading into and through their business operations, they are faced with major challenges in processing and analyzing them. Thus, the decision maker needs to reduce the volume to a manageable size and focus on those data points which are crucial to the task at hand. Hence, it is creating unprecedented opportunities for businesses to achieve deeper, faster insights that can strengthen their decision making. The human visual cortex dominates our perception. The average number of neurons in the entire human visual cortex has been estimated at around 280 million. Moreover, more than 30 million neurons are activated in the visual cortex when we see a single object image. So basically, we humans have amazing visual and spatial abilities and are able to detect outliers, variations in color, shape, and motion. Thus, one solution could be to present information in ways that engage the use of the human's cognitive and visual abilities, and data visualization is a good way of doing so. It is the process of converting raw data into some visual form, allowing the human to get insight into the data, draw conclusions, and come up with hypotheses. It helps by shifting the cognitive load coupled with the understanding of big data to the human perceptual system through graphics and visuals. This is achieved by integrating the users in the data analysis process, applying their perceptual abilities. Furthermore, coupled with the computational power of today's computer systems, we can go one step further and recognize that people with machines are much more cognitively powerful than a single person or machine alone. So data visualization has been around for a while now, but just recently, with the rise of what we call today big data, we are starting to recognize its capabilities. So let's quickly run through the history and evolution of data visualization. This graph provides a density estimate that is based on significant events in the history of data visualization from the 1500s to our present time. So, in the 16th century, the earliest forms of data visualization arose in forms of geometric diagrams, graphical positioning of stars, and in the making of maps to aid navigation and exploration. And by the 17th century, we started to see physical measurements of time, distance, and space for fields such as astronomy, map-making, navigation, and territorial expansion. This here is an example by Michael Florent van Langren, who is a Flemish astronomer to the core of Spain, and in 1644 believed to be the first to present a visual representation of statistical data graphing the determinations of distance and longitude from Toledo to Rome. Now, along with the statistical theory in the 18th century, abstract graphs and graphs of functions became more widespread. William Playfair, a Scottish engineer and political economist, was believed to be the first who invented the line graph and bar chart in 1786, and later in 1801 the pie chart and circle graph. We can see in this graph that Playfair presents a more sophisticated graph whereby he used 3 parallel time series to show the price of wheat, weekly wages, and reigning monarch from the years 1565 to 1820, illustrating an example of how data visualization was used at that time. By the 19th century, an explosive growth in statistical graphics and thematic mapping emerged. Many of today's modern forms of data visualizations were developed, such as bar charts, pie charts, histograms, line graph, time series plots, scatter plots, and so forth. By the mid-1800s, all conditions for the rapid growth of visualization have been established, and what was known as the golden age of statistical graphics began. This graph shows a good example of how data visualization was at the time of the golden age, where it uses polar time series diagrams on a map of France to show the changes in population by department at the 5-year intervals of the national census from 1801 to 1881. Now, opposed to the golden age of statistical graphics in the 1800s, the early 1900s could be called the modern dark ages of visualization due to the influence of the formal and numerical zeitgeist from the mid-1930s on. However, in the mid-1960s, data visualization began to spur and rise. John Tukey, an American statistician, issued a call for the recognition of data analysis as a legitimate branch of statistics, and by 1977 he introduced exploratory data analysis. Finally, and with the introduction of high-dimensional data in our current era, new and advanced techniques such as scatter plot matrix and parallel coordinates were developed. So in general, there are 4 main stages to data visualization. First of all is the collection and storage of data. Following that is the processing of data, where we provide some structure for the data and remove all but the data of interest. Then the hardware used for display and the algorithms used to visualize the data. And finally, and most importantly, the human perceptual and cognitive system, which is basically the process of thinking. A final stage can also be added here, whereby we can provide interactability with the visualization, giving the users the ability to manipulate the data or control what features are visible. David McCandless here shows us 4 elements of a good visualization. Interestingness, which is making sure the audience care about what you say. Basically, the visualizations need to be relevant, meaningful, and new. Integrity deals with the question of whether you're saying the truth or not, and whether you are consistent, honest, and accurate. Form is whether you are saying things in a nice to hear way. Basically here your visuals should be beautiful, structured, and have good appearance. And finally, function, which is concerned on whether you are able to make what you say easy to understand. So for example here, if you have integrity, function, and form, but without interestingness, your visuals will be... if you have integrity, form, and function without interestingness, integrity, function without form, your visuals will be ugly. But on the other hand, if you have integrity, function, and form, but without interestingness, your visuals will be boring, and so on. Let's quickly talk about some of the benefits of data visualization. To begin with, it can easily deal with highly diverse and noisy data. Also, it is intuitive and requires no understanding of complex mathematical or statistical algorithms. And furthermore, it usually allows for faster data exploration and often provides better results. It also offers the ability to detect exceptions in the data. And finally, it may be useful in quality control, meaning that with an appropriate visualization, errors and artifacts in the data often become visible. Let's take a look at this example quickly. If I asked you to count the number 7 for me, you might try to count row by row, but let's say there are thousands of numbers instead of what we have here. You might just end up getting a headache. But if you use a simple algorithm, you might get results similar to this, something that just would simply direct you to the location of the number 7. But if I were to do this instead, now you can easily see the 7. So by simply visualizing the number 7, by adding color to it, we can easily pinpoint it out from the rest, saving time and effort. But that's not all. By doing so, our perceptual and cognitive system can now start detecting patterns. Now we can see a cluster of 7s grouped towards the left side and a single outlier towards the right. Here we might start asking questions as to why this is and probably pursue further investigation. So visualization leverages the abilities of our eyes and brains and helps in detecting patterns or pattern violations fast and efficiently. This here is another example of using visualization for outlier detection. By looking at this, we can clearly see some deviations from the norm. Such instances are considered outliers and are visually detected. Simple changes in skew, position, color, size, blur, or even shape of different objects in the visualization can be detected by our powerful visual capabilities. Now let's look at examples of some data visualizations widely used. First of all is the bar chart, one of the most simplest forms, but still very effective. It can help us get a better sense of the data and may be helpful in detecting strange patterns or outliers. Next is the bubble chart, and when used correctly can do amazing things. Basically, it's a scatter plot with additional dimensions added that can be presented in terms of bubble size and or color. Here we have a heat map, where values are represented by colors or their intensity. They too can help to quickly identify outliers in the data. In heat maps, values are presented in a matrix and represented by colors. Size of the boxes can also represent additional attributes. Next we have Geographic Visuals, which are visualizations that support geospatial data and are very helpful when dealing with addresses, zip codes, or even cities. Box plots are extremely useful in that they show a lot of information about a variable in one plot. They can show the median, range, and potential outliers in one visual. Time series, on the other hand, is useful for visualizing a sequence of data points, measured typically at successive points in time. Clustering is a more advanced visualization technique that deals with grouping a set of objects in such a way that objects in the same group are more similar to each other than to those in other groups. This is a very useful technique for detecting outliers. Network graphs are now becoming more popular, with social media being widely used, because they specialize in modeling pairwise relationships between objects. Now, a much more advanced technique is a combination of clustering and network graphs, or network clusters, where we group a set of similar objects and model a pairwise relation between them. Finally, we have visualization dashboards. These dashboards enable many different visualization formats to be presented to the user simultaneously, instead of having to present one at a time. They provide interactability and flexibility for the user. Now let's go ahead and look at a real-world example of how we can use Tableau software to analyze our data. So let's go to Tableau to show you a real-world example. This is where you can download Tableau. We will provide you a link so you can download Tableau later to work on your assignment. It's free for students by using your student or Rutgers email address. Now going over to Tableau, first of all what we need to do is connect to the data. So Tableau has many different formats in which you can import your data file. You can use Access, Microsoft Excel, or even a simple text file like a CSV file. But for this example, I already have a file ready, so I'm going to use a Tableau data extract and open the sample file I have for you guys. Now, first example I will be showing you is how you can utilize Tableau to show sales trend, gain insights, and potentially produce some forecasts. So what we will do now is simply drag. First of all, let me just give you a brief, idea of what Tableau has. So here you can basically view your data. If you go to data, this is the underlying data that we will run our analysis on. As you can see, it's a huge data set, many attributes, columns, and many rows. And by just glancing at the data, you probably won't get anything done. So hopefully, with some visuals done, we can gain some insights and draw some conclusions. The nice thing with Tableau is kind of categorizes for you some of the attributes, dimensions here, and the measures, and then sets down below. So let's get started here. First of all, like I said, we want to look at the sales trend. So we will drag sales and place it on the row shelf. So this basically shows us how, gives us a sense of how sales have fared overall across time. Across all our data. But if we want to look at it across time, we would need to get the order date by simply dragging the date, here and placing it on the column. And here what we have is, kind of get a year-to-year sense of how sales have trended. Now we can also break this down further and see quarter to quarter. If we simply just click on this small plus sign, and we have quarter to quarter, and we can also kind of overlay the sales in one graph. So by simply getting clicking the year and just choosing color. So what we have here, we'll still have quarters, but all the years in different colors overlaying in one graph. So another thing we can do here is see the sales as a continuous month stream. So if let's say we don't want to see the sales, we just want to go down here and drill it as month to month. So we kind of get a sense of how sales have fared, on a month to month basis. And then we can also slice this down further by, let's say, region. So we have different regions where our company we sell our products. So if we kind of filter this by region, get a sense of how the international department in our region fared compared to the United States, the Central, East, South, and West. And as you can see here, the international sales are much higher compared to the rest. We can also kind of categorize this by department. So if we want to see which department is doing better compared to the rest, we can again drag department into color, and now have our 3 departments and see the sale trend for each one. Now generally different users have different criteria. So one thing we can do here is create somewhat of a filter. So let's, for example, kind of let's say we want to focus on the furniture department, for example. So we can again go to department, drag it. Instead of dragging it to the color like we did before, we're going to place it in the filters, and we have this filter pop up where we just click OK, and then right click on this, show quick filter. So now we have a filter, and maybe we want to change this into single value list. So now we can select whatever department we want. So if we want to look at the office supplies, we want to look at technology, or we can look at all 3 together. So this is one one visual we can do to see how sales have fared over time. If we want to see how sales may fare in the future, Tableau has this nice feature where if you right click and go to forecast, show forecast, kind of provides you with approximate forecast of how your sales might do in the next year. So it's not 100% accurate, but it's a nice way of giving you a sense of how this works. And let's take this out and let's rename this sheet to sales trend. Okay. So basically this is an example of how we can analyze historic trends in sales and see how the company is doing, and possibly compare different departments over time. And if you want to see future forecasts, we can easily right click on the graph and just choose show forecast. Let's go on to another graph. Let's now do some geolocational analysis. Let's say we are interested in seeing how sales are doing across different countries. So again, the first field we want to see is sales. So let's drag sales to rows. And now we will drag country data. So let's go to countries, and let's drag country to column. Here we can see each country and how it kind of total sales, how it fared in total sales. But we don't want to see this view. We want to see a map. So we can go to the Show Me tab, click on this, and we have 2 geo maps here. One here and the other one is here. So we can choose either one. Let's stick with this one. Now let's say we want to narrow this down further by state level or even city level. So we can click on state, drag this down here below country. So you can see we get different states in the United States, and in Brazil we have different states in Brazil, and we can even drill this down by city. So if you drag city down, so we've drilled this down even further by city. So here basically we get a sense of how different cities across the world are doing in terms of sale. However, this doesn't really give us an accurate sense. So what we might want to do is actually look at profits instead. So what we can do here is just simply drag profits to the color coding, and basically what we get here is the darker green is they have very high profits, and the light green and we can see here we have like a slight red, which means some losses. So so as you can see, most cities are profitable, but I'm sure we have some losses, but again it's probably not showing very clearly here. So one thing we can do is again create another filter here. Let's kind of do something first here. Let's slightly change this to add some borders, and now let's create a filter for profits. So we drag in profits here. We want the sum. So let's say we want the sum to be 0. Then we click OK. That's the maximum, at most 0. So let's say OK. So now you see we only have basically the losses in across the globe, where our sales where we have losses in different countries. And also if we want to focus in the United States, we can simply click on country, add a filter as a country, and go down to United States, click on this, click OK, and now we only focus on the United States. And by just glancing at this, we can easily see that Florida has the highest losses, Miami, Florida. So again, we can right click on these and show quick filter, and then we can go back, just look at the entire profits, not just the losses. And also we can click on country, show quick filter, and click all, so we can see the entire globe, not just the US. So let's name this let's say world sales. Now let's create a final visual. So based on the geo map, we saw some cities with losses. So this can be attributed to many things, but maybe one of these things can be potentially shipping costs, because we saw in China we had some losses, and in Brazil. So maybe this maybe shipping costs has an influence here. So let's create a third visual. So let's start by placing profit in the rows shelf, and then shipping costs in the column shelf, and then let's go and get product. Yes, product. So let's get product category and place it on shape. Actually, let's do something else. Let's place country region to shape. Oh no, sorry. Instead of country region, just region to shape. So at least we can get instead of having all these countries, we'll have just international representing all the others. And then now we can get product category and place that to color. So now we kind of get a sense of get an idea of where we have high profits in certain products and a low losses or low in others. But we could also get kind of get a customer's further customer details on this. Let's just drag customer and put in detail. See, now we have a better view of a comparison between the shipping and profits. So basically what this graph does is it shows us the sum of all shipping costs and profits for all transactions per customer. And for what we can see here is many customers with low profits. So this is the zero line. So all these customers below the zero are producing losses for us. So this is definitely something users want to look at into and investigate. So again, we can add some filters here. Let's look at some trend lines. So a nice feature here is that we can right click and look at trend lines, show trend lines. So again, these are all the the product categories. So we can see which products are kind of below the profit margin, and also get a sense of as shipping costs increase. Some we have some products have actual profits, but some are actually decreasing. going down. So for these products, as shipping costs increase, their profit margin is decreasing. So we're getting losses for these products. So again, that's a nice thing to see. Okay, let's take this out. Okay, now let's kind of let's name this first. Shipping costs and sales. Now let's merge all these and create a interactive dashboard where a user might want to look and be able to have more accurate sense of for the overall data and probably get have better decision making. So this is the dashboard screen. We created a dashboard, and let's drag our sheet that we created to the dashboard. So first of all, we have the world sales. Let's add the sales trend, and let's add the shipping cost and sales. So we don't want all these filters, so let's remove some. So let's remove this, remove this, take this out, this as well, and this. So now we have all these filters that we created for each separate graph, but we need to kind of make sure that they are applied to all workshops or worksheets. So we need to apply this to all, apply this to all, and apply this to all. Okay, so now we get a get a good sense of our sales data and how we're faring in different cities in the world and also across time. So again, we can, if you want to only look at the losses, so we can easily click on this, click 0. Now we can see where we have losses in different countries. If we want to focus on different departments, so let's see, we look at furniture. So we can, as you can see, furniture is really producing a lot of losses in terms of compared to shipping costs, and also in the world map. Again, if we want to focus on just let's put the profits back, but we want to focus on furniture just to see how it's faring. So see, we have countries that have profits in furniture, but again, maybe in the United States we have less. So let's look at the United States. Yeah, see, it doesn't give us a clear sense unless we compare it to. So if we drill this down to, let's say we have like $50,000 margin. Okay, let's make it lower. Yeah, see, we can drag this and kind of get a sense of how sales, how our profits are in the United States alone. But again, this is one dashboard is where user kind of looks in it, investigates the data, tries to come up with a hypothesis, ask questions, investigates whether there are certain outliers in the data, and just overall has better decision making potential. So this was an illustration of how we can use Tableau software to analyze our sales data as a real world example. And thank you guys for listening to this, and we will have a few hopefully simple assignments for you guys working with Tableau. Just one final thing I want to show you guys is for the homework. I'm going to ask you to create some visuals, simple visuals, and once you create the visual, go to worksheet, export image, and just save it as just leave these as they are. Just save it into your computer, and then you can upload it later on. So hopefully you get a sense of how to use Tableau, and the potential of how data visualization can help you in your analysis. Thank you guys. Bye bye.